Friday or yesterday. So I'm going to skip this one because I feel like for the most part we've gotten a handle on how sum and difference of two cubes works. Yes? I mean, for the most part, it is we find the value of A, we find the value of B, and plug it into either our A cubed minus B cubed or A cubed plus B cubed form, simplify where needed. Now this one here is a little bit different, but it's still going to follow our difference of two cubes, our difference of two cubes form. It's still going to follow the same method. Because the first thing we need to do is figure out what times itself 3 times is 125, which is 5. And we also need to figure out what times itself 3 times is x to the third. X. So that means for every a in our factored form here, these 3 spots here, we're going to have to replace that a with 5. So here we're just going to get 5. Here we're going to get 5 squared, and here we're going to get 5. Then we're going to do the same thing with our b term. So we're going to replace it with x. So in this first spot, it's going to be x. Might be helpful if I give myself a little bit of space. X, and then lastly, we're going to have x squared. Questions on how we got to this point here? Now we simplify the first set of parentheses. We're going to get 5 minus x. Drop the parentheses around 5, it's going to be positive. When we simplify the parentheses around x, it's going to become negative. Now in the bigger set of parentheses, the first one, 5 squared is 25 plus 5x plus x squared. That is as simplified as it's going to get. We have it factored. Now, there is another way we can actually write this. I personally would leave the first expression as 5 minus x. Because if we wanted to flip it, it would be negative x plus 5. Personally, I don't like negative x plus 5 having that negative between the parentheses and the variable. Nothing wrong with that. But what we can do is we can flip this around to have it be in standard form. So that we have x squared plus 5x plus 25. Either one works. They are both the exact same answer. One of them is not more correct than another. One of them is written in a form closer to standard form. The one in blue is closer to standard form than the one on top, but I will take both. Okay. Questions on this here? Questions on anything we've done so far? We ready for the next one? Yes? Yeah. 2p cubed plus 5p squared plus 6b plus 15. Well, one thing we can say for certain, this is not a difference of 2 cubes. Because the difference of 2 cubes has how many terms? 2. How many does this one have? 4. We have way too many terms, yes? So what we're going to do is we're going to factor this, factor by grouping. We're going to factor it by grouping. And to do that, what we're going to do is we're going to group 2 of the terms together and group the other 2. We're going to group them in even amounts. So I'm going to group 2p cubed and 5p squared. I'm doing this to try to make it a little more manageable, a little bit more easier to work with. And what I'm going to do is I'm going to look for a common factor between 2p cubed and 5p, or 2p cubed and 5p squared. Is there a greatest common factor between these two terms? P, and it would be to what power? To the second. So the 2 from 2p cubed will still be there, but the p to the third is now going to become p to the first, because we're taking 2 of them away, yes? Plus 5, because we can't factor the 5 out, we're just messing with our p squared, and if I factor p squared out of p squared, it factors out completely, yes? Okay. So, I mean, that doesn't mean a whole lot. We've just factored p squared out of both of those terms. Let's look at the next two, the last two, 6p plus 15. Is there a common factor between 6p and 15? 3, yes? Positive 3. So I'm going to factor 3 out of 6p. 6p divided by 3 would be 2p. Plus, if we factor 3 out of 15, 15 divided by 3 is? Yeah. When we factor something out, we're mainly just dividing it out. It's put out front. Because if we undid it, if we multiply 3 back through, 3 times 2p, 3 times 2 is 6. So we have 6p. 3 times 5 is 15. We get back where we started. Questions on what we've done so far? So we feel, I mean, all right, it kind of seems weird we did that, yes? But now we've gone from 4 expressions to really 2 main expressions, yes? But is there something interesting about those 2 expressions? They both have a common factor of 2p plus 5, yes? Up to this point, we have factored stuff out. We factored a number and a variable, one term. We've not so much factored an expression. And there's nothing that says that I can't go and say, both of these have 2p plus 5 in common. They both have a common factor of 2p plus 5. And we can actually factor it out of both terms because it's in common with both. We can factor it out. We can remove it from both terms. And what that tells us, we factor it out, we move it to the front. And if I factor it out of p squared times 2p plus 5, what are we left with? P squared. If I do the same thing with our 3 times 2p plus 5, we're left with our positive 3. Questions on this here? The way I like to think of this, because it is factoring by grouping, is what it's actually called, is the mathematical term for this kind of factoring. I think of it as greatest common factor twice. We do it once out of both of those two, do it again, and we have our answer. Now, before we finish, we do want to make sure neither one of these can factor any further. Now, 2p plus 5 does have a degree of 1. So a lot of our factoring methods aren't going to come into play there, so we're mainly looking for a greatest common factor. 2 and 5 does not have a greatest common factor. It is simplified. P squared plus 3 does have a degree of 2, so there's a chance we could do different methods for it. But the only real methods that we have for a sum is sum of 2 cubes. P squared is not a perfect cube. Can't do that there. We don't have a sum of perfect squares. So that is simplified. That is as far as we can take it. Questions on this here? We ready for the next one? Three n cubed minus 4n squared plus 9n minus 12. Now, realistically, how we group these up really doesn't matter. doesn't make a difference. If I group first two, last two, if I group the middle two and the outer two, or if I group the first and third, second and fourth, doesn't matter. I just go with first two, second two. Because no matter how we group it, there will be some common factor we can pull out. Now, if I look at 3n cubed minus 4n squared, what is our greatest common factor between these two? Because 3 and 4 doesn't have a common factor. N cubed and n squared have a common factor of n squared. Now, if we factor n squared out of 3n cubed, well, we still have the n. Well, we still have the 3. If I take n squared out of n cubed, if we move 2 of the n's away from n to the third, we're left with n minus. So we'll still have the 4, but the n squared will factor out completely. Now we need to look at 9n minus 12. Is there a greatest common factor between 9n and 12? 3. And we would default to positive, because I know inside the parentheses, what's inside both of them has to be the same, yes? So we want that second set of parentheses to end up being 3n minus 4. We want that first term to be positive. We want that second term to be negative. So we're just going to pull out a positive because it's not going to mess with the sign. Because 9n minus 12, positive, negative, everything's lining up. We're good there. But if I factor 3 out of 9n, 9 divided by 3 is 3, and we still have n. Minus. If we factor 3 out of 12, 12 divided by 3 is 4. Questions on this here before we move on to the next step? But doing that does give us a 3n minus 4 with both terms, yes? We do have something in common with both, it's 3n minus 4. So since we do have something in common in both, we can factor 3n minus 4 out of both of these terms here. We can remove it from both terms. If I factor 3n minus 4 out of our n squared times 3n minus 4, we're left with n to the second power n squared. And it would be positive, but we don't have to put a sign in front of it. If we factor the 3n minus 4 out of 3 times 3n minus 4, we're left with positive 3. Since it is positive, we do have to put that plus between them. Questions on this here? Questions on factoring by grouping? We kind of feel comfortable with we're starting to see this. This is above and beyond, not above and beyond, but not so much necessary. We don't have to do it. You don't have to write this. So all I've done is just rearranged it. So I'm doing the first and third, second and fourth terms. Yes? Well, 3n cubed and 9n have a greatest common factor of 3n, yes? If I factor the 3 out of 3n cubed, it's going to factor out completely. If I factor the n out of n cubed, I get n squared. Plus 3. N factors out completely. 9 divided by 3 is 3, yes? If I look at the second set of terms, they do have a common factor of 4. But if you notice, both signs are negative, yes? Those signs inside the parentheses are both positive. So I am going to have to adjust for that sign error. Because the signs are both flipped, we are going to we're still going to factor out a greatest common factor of 4, but it would actually be negative. Because if I factor negative 4 out of negative 4n squared, negative 4 factored out negative 4 would simplify, and it would turn it into positive n squared. If I factor that negative 4 out of negative 12, factoring that negative out would turn it positive. 12 divided by 4 tells me I have n squared plus 3 in common, leaving me with, did we get to the same spot? Yeah, so there's different ways we could arrange it to get there. But for the most part, it's not any different than just taking the first two, last two, doing the exact same thing. Let's look at this one here. 12n cubed plus 4n squared plus 3n plus 1. We can look at the first two terms. 12n cubed plus 4n squared. What's the greatest common factor between these two terms? 4n squared. Because 12 and 4, greatest common factor, the biggest number I can divide both of those is 4. 12 divided by 4 is 3. And when we factor out the n squared, we get n plus 1. When I factor 4n squared out of 4n squared, we get 1, yes? Now we can do it just like we've been doing. I go and focus purely on the second or the last two terms, looking for greatest common factor, going that route, yes? Or, I mean, we could skip it on this one, but the big thing I know, no matter what those two terms are, if we're going to be able to do this again, that second set of parentheses has to match the first. What's in the first? So since the first one was 3n plus 1, the second one has to be 3n plus 1. They have to be the same for us to be able to factor it out. Now, it doesn't always, it sometimes works this way, very rarely. It ends up being what we factor out is the first term. We get it to be the same and factor it out. But if that's the case, we could have factored it out from the start. Now, as y'all are saying, already pointed out, it's already 3n plus 1. Yes? So really, what am I factoring out? Positive 1. I could say I factored out positive 1 from it, or I'm just putting parentheses around it. Really, that's all I did. Now, it might be helpful to put the parentheses around it and think of it that way, so that when we go to say these two terms are in common, it gives us an understanding or an idea of what we're looking at. Because we can still factor 3n from 1 out of both terms. Because when we factor it out of our first term, what we have left is 4n squared. Plus, because that's the sign in the middle, what would I get when I factor 3n plus 1 out of 3n plus 1? 1. Because really what we're doing is we're dividing it by 3n plus 1. We're dividing it by itself. Anything divided by itself is 1. But incidentally, that is as far as it goes. That is the answer. Now with factors, no matter what we do and no matter what we do with division, we cannot divide something by another term and get 0. We cannot divide two things and get 0. It does not happen. The only way it can is if the top of that fraction or top of what we're dividing is 0. Is the only way that works. Does that make sense? Yeah, because we're saying x divided by y equals 0. Really, we're saying x is equal to y times 0 for a different number, and x and y are both different than 0. It just doesn't work. there's no way to get this to work. Seems like it should, but if this is the case, x has to be 0. Oh, or this what y'all were saying about?
Yeah.
Now, there is a greatest common factor between 224AZ and 56AC, and there is one for negative 48YZ and negative 21YZ. It is. Is there something in common with all four? Well, if we look at all four, AZ, AC, YZ, YC, there's not at least variables. Now, there might not be a greatest common factor at all, because up to this point, most of the numbers have been easy, they've been manageable, we can see what can work with them. But especially when they get big like this, if there is a greatest common factor among them, it might make it easier to work with. Yeah. Now, greatest common factor, one of the things that makes it, or sometimes can seem challenging, is just trying to figure out what even numbers do we look at to try to find greatest common factor, yes? Looking at those numbers, what is the biggest possible common factor we could have? 21. 21. Because if I'm going to look for common factors, I always look at the smallest number, 21. Because if I try to say take 30 as the greatest common factor, I know for certain 21 over 30 is not even going to get me 1. I'm going to get a decimal for sure, guaranteed. So the biggest number we could possibly have as the greatest common factor is 21. 224 divided by 21 doesn't work. At that point, I'm like, okay, we know it's not 21. I would look at the number that has the least number of factors. It'd still probably be 21, because we have 1 in 21 or 3 in. So 24 divided by 7 is 32. 56 divided by 7 is 8. What was the next one? 84 divided by 7 is 12. And 21 divided by 7 is 3. So if you already were working it and pulled out those other two numbers, 56 and 21, work it out, see where we get. You want to do it. Because what I'm going to do is, since we did see that factor of 7, I'm going to factor it out of all three terms first. Now, if I factor 7 out of 224, we get 32, AZ. Plus, if I factor 7 out of 56, we get 8, AC. Minus 12, YZ, minus 3, YC. Would we say these are nicer numbers? It's interesting, we take one factor of 7 out and we decrease them significantly. We decrease them by a factor of 7, or 1/7. But I think it's a little bit easier now to see what the greatest common factor between 32AZ is. 8A. If we factor 8 out of 32, we get 4. A factors out completely, we have Z, yes? Plus, if I factor 8A out of 8AC, well, the 8 and A would simplify out, and we're left with C, yes? Questions on this so far? Now, y'all already said it, but really the starting two terms, the greatest common factor was 56A, yes? What's 7 times 8?
56.
So essentially we still did it, we did it in two parts. But that also means that if we did 56A, we would eventually have to factor out that greatest common factor of 7. Because if we don't, it would be considered factored, not factored completely. Now, greatest common factor between 12yz and 3yz. 3y. Now, if we factor 3y out of negative 12yz, negative 12 divided by 3 is negative 4. The y factors out completely, leaving me with negative 4z. Yes? But wait. It's not the same. It's negative instead of it being what? Positive. We talked about this actually a minute ago. How could I fix that from it being negative 4z to make it positive 4z? We can factor the negative out. Because negative 12 divided by negative 3, the negative and negative make a positive. 12 divided by 3 is 4, giving me 4z. If I factor the negative 3y out of negative 3y, it's going to become plus, and we'd still have the, see. So again, I would look, I didn't say this hour, but when I do this, I look at the two sets of factors and see which one can I see the factors of easiest. If they're huge numbers, let's try to get a greatest common factor out and make it easier to work with. And then see which of the two is easier to factor. Which ones can I see the factors of first? Because once I get that parenthesis, I know what the other one has to be, and it gives me a hint at how to get there. Use what we know to find out what we don't. Now I can factor 4z plus c out of both. And what that's going to leave me with is we will have the 8a minus 3y. And what's the only thing we're missing? The 7. Interestingly enough, we don't need those outer set of parentheses anymore, because what that's just saying is that we're multiplying it by that whole expression. Well, that's the same as saying 7 times 4z plus 3c times 8a minus 3y. If we have them there, we don't have them there, it's not going to make a difference. Questions on any of this here? That finishes up what we're going to do over factoring, talking about this here. Now, this is the last worksheet with factoring. Now, we are not starting the next chapter next week. So we're not going to start the next chapter next week. What we're going to do, Monday is a built-in snow day. So we're not here anyways. Tuesday is going to be a makeup day / review day. Wednesday, we're going to go over the review. Thursday, Friday will be the test over factoring. I do a test over factoring. That's partially to make sure we're good with factoring, doing that there. Also, it is a nice test, nice 200 points. Do well on that. That's going to help your grade throughout the rest of the year. Nice test grade, factoring. All is going to be over this year. So a nice way to earn a good number of points right here early at the start. But you have the rest of the time to work on the assignment.